to the Altair SimLab tutorial. In this tutorial, we will see how to use the option crank train, which is the no brake option. Let's consider a small example of a crankshaft. Let's see the problem description. In this, we will see how to create a surface mesh first. Then we will see how to define our layered elements for fillets. We'll create a mid nodes and we'll define the no brake option. Now let's define the surface mesh. So let's import the SLB file. So before generating the surface mesh, we need to create some of the mesh controls as defined here. So we'll be defining a body mesh control with these parameters. You can define the fillet mesh control with these parameters. Also, you can define the isoline mesh control with the defined parameters, and also you can define another fillet mesh control as per these parameters. You can change the parameters based on your model. Now go back to the assembly browser. You can go to the mesh option. In that, you can select the surface mesh option, enter the parameters with average element size as 4 mm, and select the body and click OK. So now if you see, the mesh has been generated. Now let's see how to define the layered elements for fillets. You can go to mesh. Next to CFD mesh, more options, and that the layered option. You can use the options and the parameters as defined here. You can select the layered thickness as uniform and select the fillets. Go to the selection list entity and select the option as fillet selection. You can say right click and say identical fillets. Make sure that you have selected all the fillets. You can enter the number of layers as 2, the total thickness as mentioned, the element type as dead, the mesh size, and you can define the directions, and you can click OK. So you can see that the layered elements have been defined. Okay, now let's see how to create the mid nodes. We can go to mesh, nodes, create. We can select the midpoint option. You can select the 2 nodes of the cylindrical face to create the mid node. Similarly, you can repeat the process for all rest of the cylindrical faces, which are nothing but the journals and pens, to create the mid node for each of them. So make sure that you have created the mid nodes for each of the journals and pens. And now we see that the mid nodes have been generated. Now let's see how to define the no brake option. You can go to Advanced, Crank Train, select the no brake option. First, you can define the group of planes. You can enter the group name as General. Define the reference plane. Set one of the arc edge at one of the journals and define the plane to the particular node, which is the mid node that we had created. And you can insert the row and define the appropriate distance as required. So you can define the number of planes based on your requirement. So you can define, as we have defining it here, you can select the particular distance, and you can keep saying insert layer for the number of planes that you need to create it. And you can see that we have created different types of distances, and you can say create group. Similarly, we can create another group of planes, which is nothing but for the pins. Okay, similarly, you can define the reference plane. You can select the arc edge, and you can move the node to the mid node that we had created for the reference plane to be created. You can insert the layer and define the distances as respectively as shown here. And you can create the group. So now two groups have been created, that's general and pen. Now let's define the main plane, which is now we can select the one of these cylindrical planar faces of the crankshaft and click OK. Now you can insert a table to define the number of channels and pins. You can select the offset distance for the first one, which is nothing but the channel, and you can define the group name as we had defined already. So you can select as the channel here, and again similarly you can repeat that process for generating for the pin. You can select the offset distance of the pin. You can define the group name as pin here. Okay, and similarly you can keep inserting and defining for each and channel and pins locations. Okay, so you can define the elemental length along the circumferences as 2.5 mm. You can define the maximum distance as 4 mm, and you can define the volume mesh parameters, which is 10 coverages with the 4 mm average element size, and you can retain the rest of the parameters as shown here. Say click OK, and you can create the RPE based on the requirement as shown here. So you can select the parameters that is required for your model. Now you can select the shell mesh body, which is the surface mesh that we had created for the crankshaft, and you can click OK. So you can see that now the no break option has been generated. You can set the transparency for the crankshaft model, and you can see that all the RPE has been generated based on the reference planes that had been created. And you can also take the cut plane and check that the crankshaft and the fillets that was there, which we had created as the tet mesh, has the connectivity between them, and both are now tet curved edges, which is the second order elements.